Okay, let's get into it. So first things first, when we're using this formula right here, A equals A sub 0, e to the kt, we need to understand a couple things. Also, I want to apologize for any background sound. So A is the ending activity. So what happens at the end? A sub 0 is A initial, also it's referred to as A initial, or initial A, is the starting activity. So starting activity, final activity, or ending activity. E is the constant, which is equal to 2.71828. You learn the logarithms. And we have K, which is the decay constant. We can solve for that. There's no specific constant for everything. And T is the elapsed time. Usually depends. It could be days or, in this case, it would be days because I'm reading here somewhere days. Or it could be years in some cases. So, and right here they nicely illustrated it. So, a politician pushing nuclear energy stated that since a 50 milligram sample of radioactivity substance decays to 34 milligrams after 30 days, it would take no longer than 6 months for the radioactivity substance to decay to 2 milligrams. Okay, a negligible amount. Is it an accurate estimate? Is this a case of misinformation? This court will establish whether the statement should be removed from social media. Okay. Super political, but let's get into the math where there's no politics. So I can see that there's already two ways of going about this, and I'm going to explain both. First and foremost, like I said earlier, you do need to have some prior understanding of how E, ln, and logs work before doing this, but it's not to worry. It's not going to be a deal breaker. So, step one, A initial is the original amount of radioactivity material, and K is a negative number. So we can first start off by doing this. We have 34 milligrams after 30 days. 34 mg. This would be our ending, correct? Our ending activity equal to 50 substance decays. Okay, this would be our initial 50 milligrams of our sample. E to the 30, because 30 days. K, we don't know what K is. I'll put a little dot for times. Not 30K as in 30,000, just 30 times K. Cool. First things first, we're going to divide basic algebra. Nothing crazy. Mg. Boom. 50 mg. Now, these cancel out. 34 divided by 50. I did the prior calculation here. 0.68 equals E to the 30 times K. So, now we would be at step 2. Where if you already know what to do with logarithms, when you have an e to something equaling an integer, you take the ln of both sides. Nothing crazy so far. 0.68. Once again, this is just basic math. Nothing crazy. The hardest part is honestly putting information into the formula, making sure everything's correct. Everything else is just math. ln of e 30 times k. Obviously, as you know, this is gone. Cancels that out. This drops down. So we'd have right here the ln of 0.68 would be negative 0.3857 equals, like I said, ln cancels out the e. 30, the exponent becomes a bigger number. That's not 30.k. Let me fix that in case. I don't want to confuse anyone. Oh my god, so small. There we go. 30 times k. Now that that's bigger. So, now if we divided this obviously to both sides, basic algebra once again, we would have k, I'm just going to flip it, k equals negative 0.01286. Now, we're not out of the woods yet. Just remember this number. I'm going to erase it. You can obviously pause the video. So we had k is equal to negative 0.01286. Now we are on step 3. We're going to substitute 2 for AT. I'll just show you really quickly. So we'd have 2, because you know the 2 milligrams, equals 50 milligrams, the final. And the substance decayed even more, for 6 months, right? So this is the final. Remember, this is ending activity, starting activity. Start, ending. We found our K with the initial part. So 2, ending, equals starting, both milligrams. E to the negative, now that we found our constant, 0.01286 T. Got it? Cool. Now we're going to divide both sides by 50. Basic math, once again, mg, 50, mg, boom. 2 divided by that, that'll be 0.04. Units cancel out. E to the negative 0.01286 times T. So far, so good? Wonderful. So, our final step, you guessed it, we're doing the ln of both. That's how we get rid of the C. 0.04, boom, equals ln of e to the negative 0.01286 times t. That's gone. That's not gone. That's going to equal negative 3.2189 equals, this drops down, negative 0.0, sorry, I messed up. No, gracias. 0.1286, perfect. Times t, sorry. Now we're doing basic math once again. Sorry again for any sounds in the background. I don't have my microphone today. Boom, to both sides. 0.01286, writing out every step. We will have now, since you kind of can memorize this divided by itself, we're going to have, since you can pause the video, t is equal to 250.39 days. Because that's what we're doing everything here. We're doing it in days, right? 30 days. Here they have 60 months, but we're doing everything essentially in days because that's what they want. So, therefore, the radioactivity substance of 2 milligrams after 250.39 days. So, this is how it solved this. Mathematically, there would be a second way of doing this too, but this would be my initial way of going about it.